So here we are going to see how to calculate the thermal conductivity of composite wall. So first of all, see the specifications. So here we are going to have the dimmer stat 230 volts as well as ammeter, voltmeter and the enclosure. So here you can see the dimensions of the enclosure 300 by 300 by 300 mm and the slab diameter is 200 mm, thickness of mild steel so 25 mm and the thickness of backlight 20 mm, thickness of wood is 18 mm. So the total thickness of this 25 plus 20 plus 18 together 63 mm. So these are the specifications of the composite wall. So now coming to the observation. So what we had observed from the experiment. So we had supplied the volt meter reading, so 84 volts, and the ammeter reading, so 0.72 amps. So together we are going to get the power 60.48 watts. Right. Now coming to these thermocouple readings. So we are going to have the three sets. So in the first set, we had observed the temperatures 104, 103, 100, 98, 54, 51, 33, 37. Now after 20 minutes, so we had taken the next set reading. So the readings are 114, 113, 111, 109, 62, 59, 37 and 41. So now again after 10 minutes or 15 minutes, so we had observed the same readings similar to the set 2. So nothing but 114, 113, 111, 109, 62, 59, 37, 41. So now by seeing this set 2 and set 3, we can say that the system has reached to the steady state. So because temperatures are not going to change with respect to time. Now coming to this mean reading, so we can take first two thermocouples are mounted on the heater. So that indicates TA. So average inlet temperature to the mild steel. So T1 plus T2 by 2. It is 114 plus 113 by 2. So that indicates TA. So if you calculate the average temperature of TA will be so 113.5 degrees centigrade. In the same way, if you calculate the mean temperature of next thermocouples 3 and 4, so the temperature is 110 degrees centigrade and the next TC, so average temperatures for the next thermocouples. So TC will be 60.5 and TD will be 39 degrees centigrade. So these are degrees centigrade, right? This is the average temperature readings. Now coming to the calculation part. So I had already explained you. So the location of thermocouples. So here you can see. So in center, this is the heater. Black one is the heater. So one thermocouple is placed above the heater and another thermocouple is placed below the heater. Next, this is the mild steel. So one mild steel above the heater and another mild steel plate below the heater. So again two thermocouples. This is one thermocouple and this is the next thermocouple. In the same way, wood. So these are the two thermocouples on, sorry, backlight and the last one is wood, right? So this is mild steel and this is backlight and this is wood. Now coming to the calculation part. So here, so the Q we had supplied is 60.48 watts. Now coming to this heat flux. So heat flux is nothing but heat supplied per unit area. Heat supplied per area. So Q by A gives us the heat flux. So why we are going to divide with 2 means here we are going to supply. So this here we are going to supply the heat to the top side as well as bottom side. So that's why we are going to divide by 2. Okay. So Q by 2. So we are going to divide total heat into two parts. So upper plate as well as lower plate. So that's why we are going to take the 2 here. So Q by 2A. So actually Q is equal to heat flux is equal to Q by A. Okay. Here we are going to divide this Q2 into two parts. We are going to supply that Q for two plates. So above mild steel and below mild steel. So that's why we are going to get Q by 2 and area. Right. So if you calculate this value, so we are going to get Q is known to us 60.48 and area is pi by 4 d square. So if you calculate this, so it will be around 3852. So here you can calculate the area. So diameter of plate. So here you can see in the specifications. So here you can say, take this as the total slab diameter. So if you divide that, we are going to get diameter for one disc. Okay, this is for total two discs. So one disc, the diameter will be 100 mm. So if you convert these into meters, it will be 0.1 meter. So here you can substitute pi by 4 into, so D is half diameter of plate. So it is zero point 0.1 whole square, right? So if you calculate that, it will be around 7.85 into 10 power minus 3. So is it clear? We are going to take the half diameter of the plate. So that's why we are going to take 100 mm. Now coming to this total thermal resistance of the composite slab. So it can be calculated by R is equal to TA minus TD by Q. So TA, so what is the temperature of TA? 113.5 minus TD is 39 by what is the heat flux? So it is 3852.22. So the thermal resistance will be 0.019, right? Next, in the same way, calculate the thermal conductivity. So K is equal to Q into B. So heat flux is 3852.22 into, so what is the total thickness of the composite slab? So it is 63 mm. So if you convert that into meters, 0.063, okay, divided by TA minus TD. So TA is 113.5 minus TD is 39, right? So if you calculate this, we are going to get the thermal conductivity of the composite slab to 3.25 watt per meter Kelvin. So this is K for total slab. So in the same way, we are going to calculate individual thermal conductivities for mild steel as well as bakelite as well as wood. So before calculating thermal conductivity, we are going to calculate thermal resistance of mild steel, thermal resistance of bakelite, thermal resistance of wood. After that, we are going to calculate the thermal conductivities of mild steel, bakelite and wood. So we can see how we are going to calculate for mild steel, thermal conductivity for mild steel. So by using these, you can calculate thermal resistance. So directly you can substitute here and you can calculate the thermal resistance. Okay. Now I'm going to show you to calculate the thermal conductivity of mild steel. So MS. So we can use the equation TA minus TB by Q. So what is the TA? So Q into, so thermal conductivity is equal to heat flux into total thickness, sorry, mild steel thickness d1 divided by TA minus TB. Okay, so heat flux is 3852.22 into, so what is the thickness of the mild steel? So here you can see in the specifications. So thickness of the mild steel is 25 mm. So that convert that into meters. So it will be around 0.025. Okay, by Ta minus Tb. So Ta temperature 113.5 minus Tb is 110. So if you calculate these, the thermal conductivity will be around 27.5 watt per meter Kelvin. In the same way, calculate for backlight. So Q into, now we need to take the thickness of the backlight. So you can take B2 by, so temperatures for the backlight. So TB minus TC. So if you do the calculation, it will be around 1.55 watt per meter Kelvin. And the last one, wood, thermal conductivity for wood. Q into thickness of the wood. You can take B3 as thickness, TC minus TD. Okay. So the thermal conductivity will be around 3.22. Okay. So if you see, now we are going to draw the graph between these backlight, mild steel, backlight as well as wood, right? So on the x-axis, we are going to take the thickness. On the y-axis, we are going to plot the temperature. So here, so while drawing the graph, you need to consider the thickness on the x-axis. So from here, the thickness of the mild steel is 25. Next, the thickness of the backlight is, so what is the thickness of the backlight? So it is 20 mm. So we need to add plus 20. So we need to mark at 45. Okay. So generally students will draw in the same manner. So 25, 35, 45. But from starting, so the thickness of the mild steel is 25. Okay, 25 next. Plus, what is the thickness of the backlight? It is 20 mm. So we need to add plus 20. So it will be 45. So here we are going to draw the line for the backlight. Next, plus what is the thickness of the wood? It is 18 mm. 45 plus 80, total 63. Okay, so the remaining is temperature. So, and in the results, you can write down all the thermal conductivities. Thermal conductivity of the composite slab as well as thermal conductivity of mild steel, bakelite and wood. So, this is how we are going to calculate the thermal conductivity.